We're going to be good at this. Use the values secant x equals -3/2 and tan x greater than 0. Okay, to find all 6 trig functions. Okay, now for these specifically we need a diagram. Okay, and thinking of your unit circle. So we're going to draw a coordinate plane. Okay, now somebody refresh us. What is the cofunction of secant? And yeah, if you do look on the board, you can see it, what the cofunction is of secant. So anybody see from the board what the cofunction of secant is? Raise, please. Joel? It is cosine, okay? So cosine is defined from SOHCAHTOA as adjacent over hypotenuse. So anybody know what this would be then? Would be what word over what word? Cosine is adjacent over hypotenuse. This is the reciprocal of it. Raise, please. Yes, Demi? Or Remy?
Hypotenuse over
hypotenuse over adjacent. There is a Demi. Okay? So h over a, does that make sense, guys? Okay, here's some more information that we can take from the given. We can say that secant and cosine are negative, because this is -3/2. And we can say that tangent is positive. Now, in our quadrants on the unit circle, anybody remember what 2 quadrants cosine was negative in? And cosine is like your x. Raise, please. So what 2 quadrants was cosine negative in? Cosine is like your x. Rachel? 2 and 3. Very good. So out of those 2, which one was tangent positive in? Brianna? 3. Very good. So now we know our diagram is going to be in quadrant 3. Now, anybody have questions about that? Anybody have questions about that? Does that make sense? Okay. All right, so draw your diagram. Draw the terminal side. Oh, yeah, we're back to that again. Drop your altitude to the x-axis. Put in angle x as the reference angle. Okay. And Remy told us that the hypotenuse is 3 and the adjacent or next to x is 2. And one of them has to be negative. Now, even though I put a negative up top by the 3, can the 3 ever be negative, guys? No. So that has to be the negative. Okay, everybody good? Now, let's go and got a red line, and I don't know why I have a red line. Let's go and Pythagorean theorem to find our missing side. All right, did some of you guys start that already? So we're going to have -2 squared plus b squared equals 3 squared. So 4 plus b squared equals 9. Minus 4 minus 4. B squared equals 5. So b is square root of 5. Did I lose anybody there? Is everybody good? Square root of 5. Do we want positive square root of 5 or negative? We're going left and then we're going down. Negative. All right, good. All right, now we have that. We can set up our 6 trig ratios. All right, so we have sine x. And underneath that, we have cosecant x. We have cosine x. And under that, we have secant x. And then we have tan x. Oops. And then we have cotangent x. All right. Off we go, Miss Hannah. If I put my finger on the angle, sine is opposite over hypotenuse. So what have I got, madame? So negative square root of 5 over
3.
Sounds good. Is that allowed? Can we have a root on the top?
Yeah.
Yes, we can, so we're good. Now, for cosecant, we have to flip it over. So 3 over negative square root of 5. Is that allowed, guys? No. So let's rationalize. And so we get 3 root 5 over 5. Now, did I go too fast? Everybody remember how to rationalize? And don't forget, I have a negative on the bottom. You can leave it on the bottom, or you can put it out in front. It doesn't matter. Or you can put it on the top. Okay, good job, Miss Hannah. Let's ask Miss Kayla. Next one, cosine is what word over what word? What word over what word? Okay, so what's adjacent? And hypotenuse? And Miss Kayla, is that allowed? Yes, it is. Sounds good. All right. And then Joel, flip it over. There you go. Everybody good? Okay, sounds good. Matt Sarver, tangent is opposite over adjacent. Yeah. And Matt Sarver, what's a negative divided by a negative? Yes. So root 5 over 2. Okay. And then let's flip it over, guys. So 2 over root 5. Is that allowed, lovely Autumn?
No, it's not. So
No, it's not.
2 to 5 over 5.
Very good. Okay. So how are those? Not too bad? Those are easy, right? Okay. All right. Now, hang on. All right. Does somebody know what I could replace either of these with from row 1? So Vanna, go ahead and show row 1 of stuff up there. Very lovely. Okay, so is there anything up there I could replace possibly cosecant with? Raise, please, if you see anything. Remy?
1 over sine theta.
Very good. I would never leave cosecant as cosecant. I would replace it as 1 over sine. Vanna, can you show the one? Thank you. So 1 over sine theta times cosine theta. Now, Vanna, you are done for this example because you don't have to point to anything else. Okay, well, I'll let you know when you can point again. Okay, now you guys just did some problems on multiplying fractions, right? So does anybody know how to multiply these two fractions together? So multiply across, so tell me what you'll get. Raise, please. Who am I talking? Brianna, what will you get?
Cosine theta over sine theta.
And actually, Vanna, we do need you again.
Yes.
Does anybody see anything from the top row? Again, Vanna, show the top row, like you did before. Does anybody see anything from the top row that we could replace cosine theta over sine theta with? Raise, please. Don't just yell it out. Yes, Kayla. All right, Vanna, show us cotangent theta. No? Which one is Kayla talking about? There's another one up there. Good. Do you see cosine theta over sine theta is actually cotangent theta? There. Does that look nice and simplified to you guys? A nice little compact answer? Yes, it does. Very good. All right. Next one, secant theta divided by cosecant theta. I never leave secant and I never leave cosecant, just so you know. Okay? So Vanna, head on up again.
Okay.
Again, we're looking at the first row. Anybody see anything we could replace secant theta with? Vanna? Okay, can you show us that card, Vanna? See, that secant is 1 over cosine theta? Very good. Let's write that. 1 over cosine theta. Over, and I never leave cosecant either. I never leave cosecant. So Vanna, do you think you could find a card that we would replace cosecant with? Up in row 1? What?
Yeah.
Which one?
What
What?
you say? Oh wait. Cosecant?
Yeah. Very good, Vanna. Very nice. So we can replace cosecant with 1 over sine theta. Thank you, Vanna. You don't have to point anymore right at this moment. Now, I know you're going, what the heck is this mess I've got going here? Well, we're going to change this division bar into a division symbol. So we're going to write 1 over cosine theta divided by 1 over sine theta. We haven't really changed the problem, we just changed how it looks. Now it's division. Okay? Now, anybody remember from their math basics that what do we do instead of dividing fractions? Go ahead, Remy.
If you multiply them and then change the second one to reciprocal?
You reciprocal the second one and change it to? Very good, yeah. So 1 over cosine theta stays times sine theta over 1. Okay. Lovely, Rachel. Can you multiply the numerators together? So 1 times sine theta is?
Cosine theta.
Careful.
Oh, the numerator.
Yep.
Sine theta.
It's sine theta. We'll give you a second chance, Mrs. Rachel. But multiply the bottoms.
Cosine theta.
Yes. And Vanna will now show you the card up in row 1 that we can change. Sine theta over cosine theta, Vanna, is?
Wait, what?
Sine theta over cosine. Which card allows us to change sine over cosine to something? So find a card that has sine over cosine. Very good, Vanna. Tangent theta. Now, does that look like a nice little compact answer, guys?
Yes.
Compact answer? Sounds good. Flip it over to example 3.